Our next speaker is Evgeniya Sukhodolskaya from Qdrant. She's developer advocate there as well. And Jenny will briefly remind us what semantic search is and show us what a vector search database like Qdrant can provide beyond semantic search. She will demonstrate how to build build in N8N a reg recommendation chatbot and why it is better than asking GPT to recommend something for you. So, you ready to be amazed, Jenny?
Yeah. Firstly, Bart, kudos on the second time. Your surname pronunciation of mine was Chevskis. But so I would consider it the best start. And actually, circling back to Max, I had a couple of times also explaining to people what is developer advocate. And I think I developed my own formula. I call developer advocate stand-up comedian in IT. So like when you take the both and you just combine it in one. So I'm here to entertain, and I'm gonna do exactly what Bart read. And I hope after all of these cool things with the AI sprint, I won't make you disappointed, because honestly, I am looking at Max's job with a little bit of fear, because he's setting the plank for others here, and I want my sleep. So guys, you don't do that to your colleagues in the field. So I'm gonna firstly throw in a very little slideshow explaining what is vector databases. I'm pretty sure you all guys already know what is that, but it's just a general reminder. And if you don't know, it's gonna be clearer. And then I'm gonna show a little demo, and I mean, let's see how it's gonna go, but I hope it's gonna work out and you will like what we built yesterday with Oleg. And also, I want to separately say kudos to Oleg. He wanted to call me yesterday for 30 minutes to go over the case. We spent in the end 1 hour, 30 minutes talking about bugs in the both sides, and I loved it, honestly, so much. I think we did something very fun. So, about vector databases. So, what are we talking here about? I guess. Have a good week. Okay, so the first thing that you have to start with explaining what is vector database is about embeddings, and embeddings is simply vector representation of all data that surrounds you. It can be textual, it can be image, it can be audio, it can be video, it can be anything. It's just one of the ways to present your data in machine readable format that you can basically perform some mathematical operations on it. For example, the operation of similarity. So in this space of representations, some things, which example like text, would be similar, say cheese and Gouda. It's semantically similar things, so when presented as neural embeddings, they're going to be pretty close. And this is exactly where we get these representations from. We get them from neural networks, which are like now super big thing. I think basically you can't find a person who doesn't know about them. And this is happening, like these representations are possible because they see, for example, if we're talking about text, they see so much text that at some point they develop this pattern understanding and see that some words are belonging together and they're more similar, and some words are like more far apart. And in this numerical representation, vector representation, we can then perform different operations. And I mean, here is an example, like, no words overlap, no whatsoever, but it's very simple sentences to us. And why, what in this picture doing vector databases, where they are about searching this information, this encoded mathematically information in a very big space of these representations, because if you can imagine, if we are working with data, at some point we have a grandiose, like the amount of points is humongous, the amount of data that we want to see, to compare its similarity, find out what is similar, find out like what is there. And for that, we need a specific instrument. So it was the same for relational databases, which stored the data in a specific format. But with these embeddings, which are coming from neural networks work, we need a specific tool, and these are vector databases because they allow to store these vector representations of documents that you are searching, of sentences, of text, of images, of videos at a big scale, which happens usually when you upload the data, you encode the data, you store it, and then at the inference moment with vector databases, you just ask some question. It's also converted to this mathematical vector representation. And then in this huge space that we have behind stored in the database, huge space of points and representations, we find a similar candidate. I am going to actually show you when I'm going to be demoing a representation of films, which are going to be encoded as this mathematical vectors and shown as a points, how like our database combines them together behind, like under the hood. So why they're so big right now, this vector databases? And I think now I'm going to say the word which now people either hate or love. It's literally RAG. It's like retrieval augmented generation. And I think that was the catalyst of the popularity of these vector databases, because they are used under the hood with these models. Because when these models arose, like 2-3 years ago, we saw their potential. We were like, wow, finally we can throw away Google or whatever is that and ask any question in a simple form to this model, and it's going to provide me with an answer, and I'm going to live in a perfect world where I will know everything. But then you start noticing that when you provided questions, it starts sometimes generating some very strange stuff, which is not true or which is absolutely like not related to reality. It never happened. And you think like, what is that? And that is hallucinations, because even the biggest model that was trained on the biggest amount of data from internet is limited to this training data. And we can't trust it with answering our question correctly without providing to it some context, some external context. And the perfect thing for storing that context is actually a vector database, which allows under the hood to perform the fast search for something that we want to find out. For example, be it a documentation, we ask some question, it's not keys. I am going to ask like how to build, I don't know, how to build a search in Qdrant, how to install an A10 AI hosted kit or whatever. If I'm going to just search it in Google with keywords, it's not going to work perfectly, because who knows if in documentation there are like the same words that you are formulating the question. But if you're going to convert it to mathematical representation and use it in the vector database, it's going to find you a similar answer, similar chunk of the documentation. It's going to give it to our model, and it's going to generate a beautiful answer related to documentation, for example. And then we're going to see basically this powerful instrument, which allows us to have a search engine to which we don't have to specifically formulate some questions, like thinking about the keyword or thinking about how to ask something and not getting any answer. But we can just talk with it like with a chatbot. And also it's not limited only to text. It also can work with images, with videos, with audios, because everything is basically can be represented in this vector form. So I'm from Qdrant, and Qdrant is one of the vector databases, which is using one of the latest algorithms for that, written in Rust, and obviously is the best, because why I'm here if not to advertise it. But the thing is that beyond the classical search API, which some people think about semantic search and they say, okay, you can compare the vectors. Wow, is there anything else? I'm used to use my relational databases with this equal this filtering and order by. We also have that. We can provide nested filters and different types of aggregating information, not only semantically, but exactly, and all the types of combinations of that, which, like, you know, when you can take the both, like the best of both cases, it's always the perfect solution. But I guess one of the interesting features that we have, and that's what I'm going to demonstrate today, is recommendational API. And it works on the pain that some people, when they search for something, they not only want something specific, they also don't want something specific. For example, like as I'm going to present today, I'm going to do a super small short movie recommender system. Sometimes I want to watch some film which is about friendship, but I don't want to see anything about war or pain or blood, because you know what, I'm not in the mood. 2024 is already a year, you know. So that's what can be done behind in our knowledge base in Qdrant. And today is exactly what I want to demo you. I want to show you on Qdrant on a free cluster that we have. So if you want to replicate it and do it with your own data, also try it. That would be nice. I want to show you a demo of how to create a simple movie recommendation agent where you just write in the chat, hey, I'm sitting home, I want to watch something today about love, but without vampires, because after Twilight, I'm traumatized for already 10 years. And it's gonna solve your longing. And not only it's gonna solve it, but you also can do it just in NA10 and without coding, which honestly I loved a lot because I had a lot of fun yesterday trying to build that around. And that's what's gonna be about. I don't want to do this demo also from scratch. Of course, this workflow is not as big as Max showed for his AI sprint, but still, like, I mean, look at this sausage. I think I'm gonna do a detailed video. I will use the experience of Max and I'm gonna do a detailed video, I say tomorrow, doing it from scratch. But now let's just look at the components and let's just see what it can do, and in general, like, understand what is happening. So before I am gonna show that it's actually working as it intended to work, so as a movie recommendation chat rug system, I want to show the first part, which is uploading the data to Qdrant block, Qdrant vector store, because if we want to create a movie recommendation system, we want in our database to store the movie with descriptions, so they're going to be retrieved and then recommended to the user. And of course, it doesn't have to be movies, but it don't have to be movies, but in our particular case, I took them. And based on that, our model, our agent, is going to do all the recommendations without ability to invent some movies which don't exist, for example. So to upload data to Qdrant, we usually need like our cluster. I have cluster. It's actually free tier because, I don't know, it's enough. And I already have created a small so I'm going to be using this data set. I took it from Kaggle, and honestly, it's a good choice if you want to showcase something. It's top 1,000 IMDb movies with their short description, so you can see what is there. And to save your time, I'm not going to upload all 1,000 points now, because as you understand, they have to be converted to mathematical representations, or to embeddings, in our case with OpenAI model, but you can take any open source model, because guys have here also like Hugging Face, and they also have OpenLlama, if I am not mistaken. Yeah, Llama too. So to make it more fast, I just want to, in general, firstly show you how to do it for smaller amount of points. So what is happening here? We're downloading my data set from GitHub. We're extracting the file, which is pretty similar. And then let me limit the amount of points, amount of vectors uploaded to the database to 50, for example. Should be enough for the demonstration. And here we're going to, since this is the one of the containers that we are already saving for a bigger demonstration, let me create a smaller container here for 50 vectors and see how it's gonna go. And I am gonna run this. So this is gonna upload our representations made by OpenAI embeddings to our database. And it's gonna take from the data, so we can see it from here. We get the file. In the file, we have all of these movies. the classical form. And so here it's gonna take all of this information about movies, and it's gonna encode in mathematical like representation only descriptions, because user usually asking for some movie recommendation is going to ask something around description. He's going to say, okay, give me something about like love, but not much about like sweetness, school romance. And that's what we want to basically search around. And let's test this step fastly. And as you can see, they're uploading one by one to our database. And let me show how does it look here. So for each cluster, we have a dashboard. And this dashboard shows already points uploaded. And I can show for our bigger collection. So this smaller collection is creating now. You can see that now it has 20 vectors. It's going to be more when it's going to finish uploading. But let's look at already done uploaded big collection of 1,000 movies. So you can see how they are stored. We have all the metadata about them. We have a content and we have a vector representation, which is created through the OpenAI embeddings, which is 1,536 points. And we can see them on the graph, how they are looking and are they close or not. So we have all the different fun to play around. And for example, let me see in the visualize all the points that we have in our films. And for example, we see something very close on the graph, and it is here Harry Potter and Prisoner of Azkaban, and the point next to it is Harry Potter and the Sorcerer's Stone. So they are grouped by description, and you can see that the points similar to each other are about the similar films. For example, here is Star Wars and Star Wars. So the same way, when we are going to ask for the recommendation, where our database is going to find a point similar to some of the films that are already existing and point as further as possible from the negative recommendation of the user. So we can see all the 50 items uploaded, and we can already check it in our collection. So that's how it's done in general. And now I would love to demonstrate you what we did yesterday with the AI engine, because I think it's like super cool. Firstly, I want to literally show how does it work and then briefly go over it. So there is a chat, and this is a movie recommender agent. And I want to watch some film, which is about sport, but not about baseball, for example. And then we will see the recommendation being provided to us, which is going in the meanwhile to call the tool. And it's calling the tool. Oh, I love this demo effect. It's when you're doing something for 1 million times and then it works perfectly, and then the demo comes and then nothing comes. Let me try again. So I want a film about sport, but please nothing about baseball. And we got our answer. And our answer is, sorry, it was supposed to be in the chat. Yes. So the wrestler, the story of an Indian athlete and champion, and the story of a dog, which is kind of a sportsman, but not much. We can see that it called the tool, which we built here. This tool is basically our workflow. And this tool is calling our database and our recommendation API, which returns top 3 films from our database with the score of similarity. As you can see, it's not that high, honestly speaking, I guess because out of 1,000 films, we don't have so many films close about like sportsmen, but not baseballers. But actually, top two answers are pretty good. So it's about the professional wrestler, and it's about the story of an Indian athlete, and nothing about baseball. So here, our agent is just talking to OpenAI model. So it's like GPT. GPT just is used to call the tool, and it used to basically beautify the answer of the tool, the retrieval data from the database. And what is happening here? So here, we're firstly taking our positive and negative example because our model is smart enough to provide us, based on our request, a positive and a negative example. So the positive example is a film about sports, and the negative example is nothing related to baseball. And then we embed these examples in the same vector representation as we did here, because we need to compare same vectors. It makes sense. You compare something similar to something similar. Then is basic mapping of the points. We're taking our embeddings, our vector representations, and there we are sending them to Qdrant recommendation API, which basically looks like this. You provide a positive example, something that should be close, and a negative example, something that should be far, and some strategy of aggregation. After that, Qdrant returns us points. So what is recommended? You can see here, I limited it to 3 points. So it recommended top 3 points, which are the closest. We fetch them from database because we want to know what they are about. And you can see that it's fetching all the descriptions, like about the wrestler, the name, the film, and yada, yada. And then we just beautifully combine them, and then we send them to agent. And that's how our agent can basically build their answer on something which is like truly our document in the database. And I guess the cool thing is that you can do it not with just a movie data set, which is pretty easy, but you can do it with your own documentation, for example, or with your own product, or with Amazon, or with house searching. And then you are just going to say, okay, could you please recommend me something? Say I'm searching for a house, for renting a house, like house with 2 rooms, but please without like red wall colors because they make me psyched or something. And it's gonna be done with this workflow without coding in 1 click. And honestly, that's sick and I love it. So I am super grateful for the ability not only to present, but literally to just try the tool, because that was so much fun combining this simple solution.
Brilliant, Jenny. And I know how hard it used to be to build recommendation engines, and to see you do it in such a short time is it's amazing. And
Yeah,
that's
no,
also
honestly,
the
it's like kudos to you guys. I mean, also kudos to Qdrant. What can I say? But yeah.
exactly. It's a beautiful combination. And then I'm reading the chat, and people are super impressed with your tools and the visualization, that demonstration of how the movies work close together in the vector space, even though you're like flattening, what is it, 12-dimensional space to two, I imagine,
Yeah,
right?
yeah,
With
it's simplification, of course. It's like
mhm.
if I would be mathematical, it's like principal component analysis, but yeah, it's like basically flattening into 1 dimension. But
Mhm.
it's still, as you see, it grouped Harry Potters together, so
It makes
it
sense. Yeah,
makes
absolutely.
sense.
That's really good. Yeah, and I think yeah, people are saying we didn't see that in other products yet, so that is really, really cool. Um, yeah, I'm reading a lot of praise. I don't think we have a lot of questions unless someone has one right now, who wants to share one.
Oh, I noticed my CEO in the comments, so all the questions can go directly.
Great. Oh, hang on. Now there are some questions here. So Marcus asks, how would I keep the embedded documentation up to date in a vector database? I would want to have help articles updated and added, and need to embed them. Do I need to embed them once a day, or could I make sure the docs are always in the vector space? So
uh,
basically, do you need to like re-encode everything all the time, or do you have a
I
smarter
mean, you have
strategy for that?
no. I mean, it depends on the how often your data is changing, because like the new data arrives, you just encode the new part of it and add it like you would upload any data to database, right? If you want to store it there, you just upload something new, but you don't have to re-encode the old ones because they are already in the right representation there. If something changes, you will have to re-upload it just because it makes sense. Like, for example, I was storing some, say, we had like a guideline, we had our documentation, then it completely changed. You of course want to re-upload it because the old data is safe, but it is just a common sense. If your data is changing a lot, I would definitely do a day scheduled re-upload. It's fast because I mean, Qdrant is built on Rust. All the encoding is done, like we have vector stores, which is up to 520 million points, and it's working pretty fast because we have horizontal and vertical scaling. So it should be like a piece of cake.
But it's good to have a strategy in place to minimize the encoding costs, right?
Yeah, of course, of course.
So that's okay, that makes sense. Another question is from, oh, hang on, I just scroll out of view. Colleen, she said, this was great and inspiring. I started looking at Qdrant the other day and wasn't sure where to start. Will this be an available template that we can dive in and look at? So if you could share this with us, I can make sure it gets
Absolutely.
published as well. Yeah.
I would be happy to. I also was planning to do tomorrow the whole video of setting this up from scratch, but
Oh,
you
nice.
guys need to teach me how to share NA10 workflows because I think I am kindly using kindly provided Oleg's account. So he has all of my data.
We have
Yeah,
the workflow library where we can publish these. Yes.
yeah, but you know what? It's a very interesting thought and a comment to us that the person didn't know where to start from. And we're gonna, like, I would be happy if somebody reaches out to me and says, what is the problem with starting? Because that's exactly the number one thing that you would like for your product, that the people feel like they want to start. I think recently we have doing a big job of moving very easy, quick to start tutorials to our cloud. So maybe it's the nicest way would be to start like sign up in the cloud and try to just click around without even reading the documentation, because who reads documentation? You just, I was with end to end. I was like, I'm gonna figure it out.
But you had an Oleg, right? That helps.
Yeah, I mean, all it was like documentation.
Yeah, this is really cool. Let's make sure this gets published. So when we share these videos, there will be links below them to Jenny's full video as well as to the template, so you can download it and get started right away. And let's make sure to include your voucher code as well for that free 1 GB cluster.
Oh yeah, it's just for everybody, for
Okay.
everybody. You
Right.
can sign up.
Brilliant. Yeah.
There.
Let me see. Another question is from Carter Harrison, and he asks, what makes Qdrant different from other vector databases like Pinecone?
Oh, it's a oftenly asked question. I would say my personal opinion. The thing is, like, I've heard a lot of different answers based on like who is it. We have 4 DevRels, we have 4 different answers and everything. I would say for me personally, except like the scalability in the thing would be firstly the reaction on how fast we develop the features reacting to the community. If you look at the Qdrant's community, it's very, very responsive, very, very open source, and very managed. So our CTO is sitting there daily answering to all the questions because he just loves his job, honestly speaking. So for example, this visualization was a thing that everybody wanted, and we pretty fastly did it. So except from just being a good, decent product for vector search, which is already around for 4 years. So it was before the old hype and it wasn't done on the knee, like, you know, behind the scenes, behind the LLMs, thinking faster, faster, we want to earn our money. So it's not only like a stable product, it's a product which adapts to what their community needs very fast.
In a true open source
That's why I wanted to
spirit.
talk to this company, because I liked how the community works.
Brilliant. Thank you. Yeah. Let's see. I have a couple more. We only have a few minutes left, so I'm gonna pick a few. So Mark Scrivo asks, is there any way of identifying deltas of the data so that only new data is added? I think that's kind of answered already, Mark. That's like on the N8N side, you need to like figure out which data is new, right?
Mhm.
Yeah, so that we don't have like a standard process for that.
By the way, just a quick tip here. In N8N, we have a compare dataset node, which would make this easier because you just connect two inputs basically, and it would give you like a difference between data based on some criteria. So that might be a good use case for them.
Cool. Thank you. Jim Lee asks, when will we get an official Qdrant N8N node? Still too many steps, need to manually generate the embeddings for the recommend API. Would love to only just have to supply the text instead.
Well, that's not to me.
No,
That
that's not.
question
I
is
think
not
that's
to me.
Oleg. Is it on our roadmap?
I can't promise any details here.
Like I framed you, live with it. No, and I actually, when you reiterated with the question about checking if the data is same or not, I realized what you were asking about because I interpreted it wrongly. And of course, in Qdrant, you can check if there is already some data because we have payload, which is the fields which you can filter with. So when you insert, you can just addition basically the filter, how to say, condition, thank you, I'm sorry, English is not my mother tongue. So you can add a filter condition, and that will help you not to insert the same data because it's going to be already detected that it's in database. Yeah, for some reason I was trying to understand like if the data is being already saved or if it's, I don't know how I understood the question first time. Was too excited after the demo. And also I saw somebody asking the question about PDF documents and if Qdrant can work with them. Qdrant can work with every data. You just need to find a way to convert it to vector representation. And with N8N, for example, you can easily do that. We did that with Oleg yesterday. You just upload a PDF document, you split it in chunks, and you upload it to Qdrant, and it takes like what, 3 blocks of N8N? 4? Okay, maybe 4. I will give you that.
Last question because we're running out of time here. Alex asks, should we ask a Qdrant node with insert documents for the first pass, as shown as the demo, and a separate workflow with a call to Qdrant points API for upsorts to account for new source document versions? Not sure.
Like,
that's more an N8N question, Alex. Yeah, that's like your initial upload versus processing the deltas, right?
Yes, it was just a question. If we had a PDF that went through and then that was version, someone made some updates, could I overwrite the points in my collection for the old document? So when I'm chatting with it, I'm not referencing the old doc. I've managed to go in and remove those points. So my vector store is always accurate.
Firstly, I'm trying to figure out, is it question still to me or to Brad?
I guess that's a question to us. So we currently don't support the upsert in the operation for Qdrant. We support for some other vector stores, but we didn't add it for Qdrant yet. So you would have to check it yourself based on this metadata, see if it's already there and then repopulate it.
Yeah, I guess it's using API would be now the same with recommendation API. I mean, guys, faster, so many requests for Qdrant groups. I am.
Okay, so there's actually more questions here, but we're running out of time, so I'm gonna wrap up. And let me just quickly go back to my slides. Hang on. If you have other questions, guys, please head over to the forum on community.n8n.io and open a topic there, and we can continue the conversation there.